By the end of this tutorial, you'll have a fully responsive website featuring a clean, modern navigation, a scroll-driven background animation with a dynamically moving avatar, an engaging hero section with a floating avatar and concise personal introduction, a customizable timeline, a portfolio section that showcases your work and visualizes your GitHub projects, a call to action section, and a polished footer. If you have watched HTML, CSS or JavaScript tutorials and still feel confused, this video is for you. I'm not going to teach you everything. I'm going to teach you how the web actually works, so the rest finally makes sense. Let's talk about the elephant in the room. AI can already write code, so why bother learning the basics? Because AI is a multiplier, not a replacement. If you don't understand HTML, CSS and JavaScript, you won't know why something breaks, you won't know what to ask the AI. HTML teaches you structure, CSS teaches you the layout, design and visual logic, and JavaScript teaches you the behavior, the data and interaction. One important thing before we start. This video is not meant to be watched passively. If you want to actually learn and you want to avoid falling into tutorial hell, you should build this project alongside me. Pause the video, type the code, break things, and then once the portfolio is working, don't stop there. Improve it, add features, change the design, make it fully your own. Before we start coding, let's set up our assets and tools. First, create a new folder on your desktop and name it Portfolio. This folder will contain everything related to your website. Next, we'll create the avatar image. I'm using an AI-generated avatar based on a photo of myself. I upload the image to Whisk by Google and generate a modern, stylized avatar using a custom prompt. For the prompt, I focus on lighting and camera angle. I chose a teal and orange lighting setup, which will later define the overall color theme of the website. After the first generation, I refine the prompt by adding person looking slightly to the right. After 2 more generations, I'm satisfied with the result. I download the image and rename it to avatar.png. As my code editor, I'm using Visual Studio Code. You'll find a link to VS Code and all the tools used in this tutorial in the description down below. Now let's start building. Open VS Code, click on Open Folder and select the portfolio folder you just created. To create our first file, press Command-N on macOS or Ctrl-N on Windows. Save this file as index.html. This file will be the main entry point of our website. In most projects, index.html is the first file the browser loads, and it will contain the core structure of our site. To work efficiently, we'll use a few shortcuts right from the start. In Visual Studio Code, simply type the exclamation mark and press Enter to generate the basic HTML boilerplate automatically. Here you can see the basic HTML tags that define the core structure of every website. These tags describe what each part of the page represents, not how it looks. The HTML tag wraps the entire document and tells the browser that this is an HTML file. Inside it, the head section contains important metadata such as the page title, character encoding, and links to styles or scripts. None of this is directly visible in the browser. The body tag is where all visible content lives. Everything users see on the page, text, images, buttons, navigation, sections, is placed inside the body. Understanding these foundational tags is essential because they form the backbone of every web page. Once you know how they work together, building more complex layouts and features becomes much easier. To quickly preview our site, just right-click on the file and open in a browser. I'm going to use Google Chrome. And here we go, our first website. For now, it's just displaying the word demo. Let's take a moment to understand the basic structure. The title tag defines the text you see in the browser tab when the page is open. I'm going to use a descriptive, meaningful title that explains what this website is about, my name and the purpose of the site, a portfolio website for a computer science teacher and a solo developer. This way, the site is immediately clear to both users and search engines.
Next, we'll build the layout, header, footer, sections, project cards, and a timeline layout.
Semantic HTML tags are special tags that describe the meaning of the content inside them. Instead of using generic containers everywhere, like div, we will cover them later, semantic tags tell the browser, search engines, and screen readers what role each part of your website plays. For example, the header tag is used for the top section of a page or section, usually containing a logo, a title, or navigation. The main tag represents the primary content of the page, the most important information users are there to see. The footer tag is used at the bottom of a page and usually contains things like copyright information, contact details, or additional links. Using semantic tags makes your code cleaner, easier to read, and easier to maintain. It also improves accessibility because screen readers can better understand the structure of your site. And it helps with SEO because search engines can more clearly interpret your content. In HTML and CSS, IDs and classes are both used to identify elements, but they serve different purposes and follow different rules. An ID is meant to be unique. You use an ID when you want to target one specific element on a page, something that appears only once. A class, on the other hand, is meant to be reusable. You use classes when multiple elements share the same styling or behavior, like buttons, cards, or layout sections. The nav tag clearly defines a navigation area, like menus or links that help users move around the site. In this navigation bar, we are using the nav semantic tag to define a section specifically meant for navigation links. The ID Navbar uniquely identifies this navigation element. Because an ID should only appear once on a page, it's perfect for targeting the main navigation. Inside the nav, we use anchor tags to create the actual navigation links. The href attribute defines where the link should go. Right now, the href values are empty strings. This is just a placeholder, meaning we haven't connected these links to real sections or URLs yet. Later on, we'll replace these empty values with actual links. Using placeholders like this allows us to build the structure of the navigation first and wire everything up once the rest of the layout is in place. When you're building a website, a common workflow is to save your file after making changes and then refresh the browser to see the updated result. Extensions are small tools that add extra functionality to the editor and help you work more efficiently. One of the most popular extensions for web development is Live Server. Live Server creates a local development server that automatically reloads your website whenever you save a file. Once Live Server is installed, you can start it with a single click. From that moment on, every time you press Command S on a Mac or Control S on Windows, the browser refreshes automatically. Just make sure that you open the whole project folder in VS Code. This gives you instant visual feedback and lets you focus on building your site instead of constantly switching between the editor and the browser. In the main section of your HTML, you'll typically organize your website into several smaller sections, each representing a distinct part of the page. These sections act as containers for different types of content, like the hero area, timeline, portfolio, or call to action. Each section is given a unique ID using the ID attribute. The section tag with the ID hero defines this area as a distinct part of the page, making it easy to style with CSS or link to from the navigation. Inside this section, we have an image tag that displays an image. Source avatar.png tells the browser where to find the image file. In this case, it's the avatar we have generated earlier. The alt attribute provides alternative text for accessibility. This helps screen readers describe the image to visually impaired users and also acts as a fallback if the image fails to load. Class applies a CSS class to the image, so we can style it specifically, like making it float, resize, or animate. In CSS, we use a separate file to control the design and layout of our website. First, create a file called style.css in the same folder as your index.html. In CSS, we target HTML elements or tags by writing their name. For example, if you want to style the entire page, you target the body tag. After the tag name, you open curly brackets. Inside these brackets, you define style rules using properties and values. Background color is the property, which controls the background color of the page. And red is the value assigned to that property. Every property value pair ends with a semicolon, which tells the browser the rule is complete. To apply your CSS styles to your HTML file, you'll need to link the CSS file inside the head section of your HTML. To link your CSS file, you use the link tag. The root selector in CSS targets the highest level element in your HTML, which is usually the HTML element. It's commonly used to define global CSS variables that can be reused anywhere in your style sheet. --bg is a custom property, also called a CSS variable. Hashtag and a value is the value assigned to that variable. Using variables makes it easy to change the color in one place and have it update everywhere it's used. Background -color sets the background color of the page. var and --bg tells CSS to use the value of the background variable we defined in root. This way, if you ever want to change the background color of your website, you only need to update the variable in root. CSS variables, like the ones you see here, make styling your website cleaner, easier, and more consistent. Each variable starts with --, and is given a descriptive name like text for text color or accent for a highlight color. Instead of typing the color everywhere in your CSS, you use the variable with var and name. And why is this helpful? First, you have consistency. Using variables ensures that the same color is applied across your website, so all text, cards, buttons, and highlights match perfectly. It's easy to update. If you decide to change your accent color or background color later, you only need to update the variable once in root. Every place using that variable will automatically update. It improves readability. Color defines the text color. Variables like primary or accent makes your CSS easier to understand. You don't have to remember what this value is. You can see at a glance that this is the text color. You can see some suggestions because I use GitHub Copilot, which creates AI-crafted code suggestions. And by hitting the tab button, you approve and apply the code to your file. Later we will turn them off. Position fixed, this property takes the element out of the normal page flow and sticks it relative to the viewport. No matter how far you scroll down or up, the element stays in place. Top and the value 0, this works with position fixed or absolute. It sets the distance from the top edge of the viewport or container. 0 means it is flush with the top. You can change it to 1 rem, 50 pixel or any value to move the element slightly down. Width 100% makes the element span the full width of its parent container or viewport. You also can use percentages less than 100%, like 80%, to leave margins on the sides. Other options include auto, this fits the content, or fixed pixel widths like 500 pixel. Background color and the variable card sets the background color using a CSS variable for consistency. Variables allow you to reuse colors across your site, making future changes easy. You can use other options like hex values, RGBA or gradients. Padding 1 rem adds space inside the element, between its content and its border. You can specify different values for each side, like padding top, right, bottom and left. In CSS, rem is a unit and it's based on the font size of the root HTML element. So when you write padding 1 rem, it means the padding will be equal to the root font size, usually 16 pixels by default. Using rem makes your spacing scalable and consistent, because if you change the root font size, all rem-based values adjust proportionally. Box shadow adds a shadow behind the element to create depth. It has 4 values. The horizontal offset, 0, there is no left and right shift. Vertical offset, like 4 pixel, this shadow moves 4 pixels down. Blur radius, this defines how soft the shadow edges are, for example 10 pixel. And the color RGBA function, this means there is a black shadow with 80% opacity. Display flex turns the container into a flexbox layout, making it easier to align child elements. With flex, you can control the direction, the alignment, and the wrapping. For example, a navigation bar or card layout uses flex to distribute items evenly. Justified content space between controls horizontal alignment of flex items. Align items center controls vertical alignment of flex items inside the container. The star is a universal selector. This targets every single element of the page. It's often used for resetting default styles that browsers apply automatically, so your layout starts from a consistent baseline. Margin 0 removes all default spacing outside elements. Many elements like H1 for headings or P for paragraphs have built-in margins that can affect the layout. Setting margin to 0 ensures you have full control over spacing. Padding 0 removes all default spacing inside elements. Box sizing changes how the width and the height of elements are calculated. By default, width only includes the content, but not padding or border. With border box, padding and borders are included in the width, so your layouts are easier to manage and don't accidentally overflow. Font family sets the default font for all elements on the page. If the first font isn't available, the browser tries the next one in the list, for example Tahoma. Point logo, this targets any HTML element with the class logo. Classes are reusable, so you could have multiple logos styled the same way if needed. Font size 1.5 rem sets the size of the text to 1.5 times the root font size, usually 16 pixel. Using rem makes the size scalable across different devices like mobile or desktop. Font weight controls how bold the text appears. 700 is typically equivalent to bold, while 400 is normal weight. High numbers make the text thicker and more prominent. And color sets the text color of the text. Now let's style our navigation. We're targeting the nav element and using display flex, which turns it into a flex container. This makes it easy to arrange all the links in a single row and control how they are spaced and aligned. Next, we add gap 1.5 rem, which automatically creates 1.5 rem of space between each link. The great thing about gap is that we don't have to manually add margins to each link. Everything stays neatly spaced and looks clean and professional. Now we'll style the links inside our navigation. We target them using nav A, which means all anchor tags inside the nav element. First we set text decoration none to remove the default underline from the links. Then we use color to make the links the same color as our text theme, keeping the design consistent. We also set font weight to 500 to give the links a medium boldness, making them easy to read but not too heavy. Finally, we add a hover effect with nav A and hover. When you move your mouse over a link, the color changes to the accent color, giving an interactive feedback that looks polished and modern. Now let's add a dark and light mode symbol in the navbar. First, let's create two divs. To integrate icons, I use Font Awesome and add a link to the icon library in the head. Now we can add the icons by selecting the specific class like FA Moon and the style FA Solid. Let's add a menu icon using FA Bars and color everything white. In the navbar you can see the links, and by pressing them they should redirect to the selected section, for example projects. To specify the destination of the link, just add the ID of the section you want to refer to, starting with an hashtag. To add content to our hero section, we'll create a div with the class hero content. Inside this container, you can use different heading levels from H1 all the way down to H6. Just remember to use only one H1 per page, as this helps with SEO and accessibility by clearly defining the main topic of the page. This structure keeps your hero section organized and makes it easy to style later with CSS. To make it more animated, I add an animated image to the project folder named Waving Hand. You can easily add an image using the image tag. Make sure the image file is in the same directory as your HTML file, so you can simply set the source attribute to the image name. If it's in another folder, you'll need to provide the full path. It's also important to add an alt attribute. This improves SEO, helps screen readers for accessibility, and shows alternative text if the image fails to load. Using source and alt properly ensures your image are both visible and meaningful for all users. Now let's style the hero section's title. We are targeting the .hero title class and using display flex to turn it into a flex container. This allows us to easily arrange the elements inside, like text and icons, in a row or column. Next, we use Align Item Center to vertically center all the items inside the flex container, so everything lines up neatly along the middle. We also add gap 0.7 rem, which creates space between each item inside the title, keeping it visually balanced without needing to add margins manually. The font size 3.2 rem makes the text large and prominent, perfect for a hero section where you want the title to grab attention. Finally, flex wrap ensures that if the content is too wide for smaller screens, it automatically wraps to the next line, keeping the layout responsive and clean. This combination of flex properties makes our hero title flexible, centered, and visually appealing across all devices. In our hero section, we want to make part of the title stand out, so we are styling the span inside hero title. First, we apply a linear gradient background from orange to a lighter orange. This gives the text a colorful, dynamic look. Then we use WebKit background clip text, which makes the gradient apply only to the text itself, instead of the whole background. Finally, we set the text color to transparent. This is necessary so the gradient shows through the letters instead of the default text color. Now let's style our avatar image. We are targeting the .avatar class to make the profile picture look polished and modern. We start by setting width and height to 150 pixels, giving the image a fixed size so it fits nicely in the hero section. Next, border radius 50% makes the image perfectly circular, which is a common style for profile pictures. We use Object Fit Cover to make sure the image fills the circle without stretching, cropping it if necessary while keeping its proportions. Finally, Box Shadow adds a soft shadow behind the image, giving it depth and making it stand out from the background. In Box Shadow there are 4 values. Horizontal offset 0, this moves the shadow left or right. Here 0 means the shadow is directly behind the element, not shifted sideways. Vertical offset 30 pixels, this moves the shadow down 30 pixels from the element. The blur radius 80 pixel, this softens the edges of the shadow. A high number makes the shadow more blurred and diffused. And the color, this sets the shadow color to black with 20% opacity, so it's subtle and doesn't overpower the element. Now let's look at the hero section itself. We are targeting the hero ID to define the main container for our hero content. We set position relative so that any absolutely positioned elements inside the hero, like our avatar or floating text, are positioned relative to this container. In our hero section, we set min height to 100 VH. The VH unit stands for viewport height, which is the visible height of the browser window. Using 100 VH means the hero section will always take up the full height of the screen, no matter what device or screen size someone is using. VH automatically adjusts to the current visible area. This is great for hero sections because it ensures that all the important content like your avatar and introduction is immediately visible without the user having to scroll. So in this example, the hero section adapts to the viewport, making it look consistent and full screen on desktops, laptops, tablets and mobile devices. In our header CSS, we add setIndex1000. The setIndex property controls the stacking order of elements on the page, which determines which elements appear on the top of others when they overlap. By giving the header a high value like 1000, we make sure it stays above other content, such as sections or images, so it's always visible even when scrolling. We are enhancing the hero section by using display flags, which turns it into a flags container. This allows us to easily assign and distribute the content inside the hero. Next, Justify Content Center centers all the child items and elements horizontally, while Align Items Center centers them vertically, so everything sits perfectly in the middle of the hero section. We add gap for rem to create space between the items inside the hero. Padding to rem gives some inner spacing around the content, so nothing touches the edges of the container. Overflow hidden hides any content that goes beyond the hero boundaries. Finally, color text sets the default text color for all content inside the hero, keeping the design consistent with our theme. Now let's add a paragraph to the hero section to give some important information about our website. Now let's style the description text in our hero section using the hero description class. We start with max width 600 pixels, which limits the text to a comfortable reading width, so it doesn't stretch too far across large screens. Next, font size 1.2 rem makes the text slightly larger than the default, ensuring it's easy to read, and line height 1.6 adds vertical spacing between lines, which improves readability. We use margin top 1 rem to add some space above the paragraph, separating it from the hero title. Letter spacing slightly increases the spacing between letters, giving the text a cleaner and more modern look. Finally, opacity 0.9 makes the text slightly transparent, giving it a subtle, softer appearance that blends well with the hero background. The opacity property controls how transparent or visible an element is. It accepts values between 0 and 1, where 0 means completely invisible and 1 means fully visible. Now let's look at the hero content container inside our hero section. We set max width to 400 pixels, which limits how wide the content can get. This keeps the text and other elements easier to read and prevents them from stretching too far on large screens. We also add set index 1, which ensures this content stays above the background elements like animations or moving images, but below the header if the header has a higher set index. Now we style all paragraphs in the hero section with a font size of 1.4 and a margin top of 1. Let's set the default color scheme to a dark mode look, which I prefer. Later on, we will add a light mode button. By adding a hero eyebrow, you enhance the hero section with a small, unique subheading above the main title. This text draws attention, adds context, and gives the hero section a more polished and professional look. It's a great way to highlight a key message before users read the main headline. Now, let's style the hero eyebrow, the small subheading above our main title, using hero eyebrow class. We use display inline block. This is a mix between inline and block elements. Like an inline element, it sits on the same line as other content if possible, but like a block element, it allows us to set margins, padding and width. This makes it perfect for small text accents like a hero eyebrow. Next, margin bottom 1 rem adds space below the eyebrow so it doesn't crowd the main hero title. Font weight 600 makes the text slightly bold, giving it subtle emphasis without overpowering the headline. Letter spacing increases the spacing between letters slightly, making the text look clean and modern. Finally, opacity 0.6 makes the eyebrow text semi-transparent, giving it a soft, subtle appearance that complements the main title instead of competing with it. All the suggested code was made by GitHub Copilot. I'm going to turn it off because I'm on the free plan and I want you to stay focused and not get distracted by the suggested code lines. For that reason, I'm going to disable the suggestions. You can also disable it in the settings JSON file. The hero section looks quite nice, but let's add some glow to the background using another div. We set position absolute, which allows this element to be freely positioned inside the hero section without affecting the layout of other content. The width and height of 600 pixels create a large shape that works well as a soft background effect, rather than a visible object. Next, we use a radial gradient as the background. This gradient starts with a soft blue color in the center and smoothly fades to transparent, creating a glowing light effect. The set index 0 ensures the glow stays behind the main hero content, so it enhances the design without blocking texts or images. Now let's add a floating animation to the avatar to bring the hero section to life. We start by defining an animation using keyframes float. Keyframes describe how an element should move or change over time. At 0% and 100%, we set transform translate epsilon 0, which means the avatar starts and ends in its original vertical position. At 50%, we move the avatar up slightly using transform translate epsilon minus 12 pixel. This creates a gentle upward motion in the middle of the animation, making the movement feel natural and smooth rather than mechanical. Next, we apply this animation to the avatar image using animation float, 6 seconds, infinite, ease in out. The name float connects the avatar to the keyframes we just defined. The 6 seconds means the entire animation cycle takes 6 seconds, which keeps the motion slow and elegant. Infinite makes the animation repeat forever, and ease in out smooths the movement at the beginning and end. To give the hero eyebrow a bit of a fun touch, yet simple add-on, I integrate a rocket emoji. Under the paragraph, I put some programming languages as so-called tech stack to highlight my foundation. Let's call the class hero stack. We start with display flags, which places all child elements in a row by default. This makes it easy to align multiple items next to each other without complex layout code. Next, flags wrap allows the items to move onto a new line when there isn't enough horizontal space. We then add gap 0.6 rem, which creates consistent spacing between each item. Using gap keeps the layout clean and avoids adding margins to individual elements. Margin top 1.5 rem adds spacing between the stack and the content above it, helping visually separate this section from the hero text. We add padding 0.4 rem, 0.8 rem to give each label internal spacing, making them easier to read and visually balanced. The two values mean vertical padding first and horizontal padding second. Next, border radius 999 pixel creates fully rounded edges, giving the elements a pill-shaped appearance. We then apply a semi-transparent background color using RGBA. This allows the background to blend slightly with whatever is behind it, creating a soft modern class-like effect. Finally, backdrop filter blur blurs the content behind the span, enhancing the glassmorphism look and helping the labels stand out without using strong colors. Comments help you organize your code by clearly separating sections such as layout, typography, animations, or components. When you come back to your project later, comments make it much easier to understand what each part of the CSS is responsible for. They also help you keep an overview as your style sheet grows. Instead of scrolling through hundreds of lines of code, comments act like visual anchors that guide you to the right place instantly. Comments are especially useful when working in a team because they help other developers quickly understand your structure and intentions. The footer is typically used to display legal information, contact details, and helpful links that users expect to find at the bottom of a page. Inside the footer element, we add a container called footer grid. This wrapper helps us organize the footer content into a structured layout, which we can later style using CSS, for example with grid or flexbox. Within the footer grid, we create individual div elements. Each div represents a separate footer section. In this example, one section is dedicated to legal information and the other to contact details. The H4 headings are used as section titles, clearly labeling what each group of links is about, such as legal or contact. This improves both readability and accessibility. Below each heading, we use A tags, anchor tags, to create links. The imprint and privacy policy links are common legal requirements in many countries and are typically placed in the footer. For the contact section, the email link uses mail to, which allows users to open their default email client automatically when they click on it. This makes contacting you quick and convenient. We start with background color and use card, which applies the same background color used in other card-like elements. This keeps the design consistent with the rest of the website. Next, padding 3 rem, 2 rem adds generous space inside the footer. The first value controls the vertical padding and the second controls the horizontal padding, ensuring the content doesn't feel cramped. We then add margin top 4 rem, which creates a clear separation between the footer and the content above it, giving the page room to breathe. Now let's take a look at footer grid, which controls the layout of the footer content. We set max width to 1200 pixels to prevent the footer from becoming too wide on large screens, keeping everything readable and centered. With margin auto, the grid is horizontally centered within the footer. We use display grid to turn this container into a CSS grid layout, which makes it easy to create clean and responsive columns. The property grid template column repeat automatically creates as many columns as fit into the available space. Each column has a minimum width of 200 pixels and can grow to fill the available space, making the footer fully responsive. Finally, gap 2 rem adds space between the grid items and keeping the footer sections visually separated and easy to scan. We continue with footer h4 and add margin bottom 1 rem. This creates space below each footer heading. Next, we style the links inside the footer by setting display block. Each link appears on its own line, which improves readability and makes it easier to click. We use color and text to keep the link color consistent with the rest of the website's typography. Text decoration none remove the default underline, giving the footer a cleaner and modern look. Margin bottom 0.5 rem adds vertical spacing between the links so they don't appear cramped. We center the content inside each footer column using text align center. This creates a balanced and symmetrical footer layout, especially useful for simple link groups. The Socials Anchor Selector targets social media icons. The font size is 1.4 rem. This makes the icons larger and more noticeable, while margin right 0.8 rem adds space between them so they don't touch each other. Let's add some icons from Font Awesome to improve the socials. We then define a hover effect using Socials Anchor Hover. When the user hovers over an icon, the color changes to accent, providing clear visual feedback and making the footer feel interactive. Finally, we add a footer text for personalization and style the footer text using footer P. Text align center centers the text horizontally, while margin top 2 rem adds space above it to separate it from the links. We reduce the size slightly with font size 0.9 rem and lower the opacity by 0.7, which is ideal for secondary information like copyright text. To make it intuitive, let's switch from the moon to the sun icon to show the toggle switch from dark to light mode and back. Let's summarize. HTML structures our content and CSS manages the styling. Now we want to make the website somewhat interactive. The line script source and script.js is used to link an external JavaScript file to our website. The source attribute tells the browser where the JavaScript file is located and which file should be loaded.
Before doing anything fancy, we'll slow down a bit and cover the fundamentals: variables, constants, functions, and reusable logic. These basics are what allow you to read AI-generated code instead of fearing it.
In this example, the file is called script.js, and because we only use the file name without a path, the browser expects the JavaScript file to be in the same folder as index.html. If the file were in a subfolder, we would need to specify that path instead. This script tag is usually placed at the very end of the HTML file, right before the closing body tag. A perfect example of using JavaScript is manipulating elements on a website through the DOM. which allows us to dynamically change content, styles and behavior after the page has loaded. The DOM, or Document Object Model, is a structured representation of your HTML page that JavaScript can interact with. Think of it as a tree-like map of all the elements on your web page: headings, paragraphs, images, buttons and more. Each element is a node in this tree that can be accessed, changed or removed using JavaScript. For example, using the DOM, you can change the text of a heading, update an image, respond to a button click, or even add new elements dynamically. In short, the DOM is the bridge between your HTML and JavaScript, allowing your page to become interactive and dynamic instead of static.
And now we are starting to interact with the page. You will learn how to select items, update content dynamically, create elements with JavaScript, respond to user actions by implementing a light and dark mode. This is where your site stops being static and starts feeling alive.
The first line is const toggle document get element by ID theme toggle. Here we are telling the computer, hey, find the button in our HTML that has the ID theme toggle and remember it. We store it in a constant called toggle. A constant is like a container that keeps this button stored so we can use it later. Next, we tell the button what to do when we click it. Toggle on click. This means when someone clicks the button, run the code inside these curly brackets. Inside the click function we have document body class list toggle light. This line is the most important. It adds the class light to the body if it isn't there, or removes it if it's there. Think of a class like a label that changes the website's colors. By adding or removing it, we switch between dark mode and light mode. After that, we check which mode is active using an if statement. An if statement is just a way for the computer to make a decision. Here we ask, does the body have the light class? If it does, we know the website is in light mode, so we change the icon on the button to a moon, letting the user know they can switch back to dark mode. If it doesn't, the website is in dark mode. So we show a sun icon, letting the user know they can switch to light mode. This way, with just a few lines of code, we can make our website interactive. Users can click a button and the website changes colors instantly. Now let's look at the My Developer Journeys section of our website. We start with a section element and give it an ID of journey. The ID is like a name tag. It lets us target this section with CSS or JavaScript, so we can style it or add functionality later. Inside the section we have an H2 heading with the text My Developer Journey. This is the main title of this part of the page, letting users know what this section is about. Next we create a div with the class timeline. This container will hold all the events or milestones in our journey. Using a separate container like this makes it easy to style the timeline and arrange the items neatly. Each milestone is wrapped in another div with the class timeline item. Think of each timeline item as a single point or event in your journey. Inside the timeline item we have another div called timeline content. This is where we put the details above the milestones, like a heading or a paragraph. For example, in the first item, the H3 says started coding, and the paragraph P explains what happened, learning Java and JavaScript basics and building the first small projects. This is where you share your story or experience. Here we target the section with the ID journey. Padding 5 rem, 2 rem at space inside the section, 5 rem on top and bottom, 2 rem on the sides, so the content doesn't touch the edges. Background sets the background color using a variable we defined earlier. And color sets the text color so it contrasts nicely with the background. Here we style the H2 heading inside the journey section. Text align center centers the title horizontally. Font size 2 rem makes the heading larger than the normal text. Color and primary gives it a highlight color from our theme. Margin top adds space above the heading, separating it from other elements. Timeline position relative allows child items inside to be positioned relative to this container. Max width 900 pixel keeps the timeline from scratching too wide and large screens. Margin auto centers the timeline horizontally. Padding left 2 rem gives space between the content and the vertical line. Border left 3 pixels solid and primary draws the vertical line that represents the timeline. Each timeline item is styled with position relative, which allows us to add effects or position child elements if needed. Margin bottom 3 rem separates each item vertically. Padding left 2 rem creates space from the vertical timeline line. We can style the timeline content using background card, which gives the content a card-like background. Padding 1 rem, 1.5 rem adds space inside the card, and border radius 12 pixels rounds the corners to make it look modern. And applying a box shadow adds depth, making the card look slightly raised. To style the content heading, we type H3, margin bottom, font size and color. To add space below the heading, to make the heading slightly larger than the paragraph, and giving the heading a color that contrasts the background color. We style the paragraph using margin bottom 0.5 rem separates paragraphs from other elements. Font size makes the text slightly smaller, and opacity 0.7 makes the text a bit transparent for a softer modern look. Now let's dive into the JavaScript that makes our website interactive and dynamic, starting with the scroll animation. Each timeline item is styled with opacity 0, hide the item, and when the item has the active class, opacity 1 makes it fully visible, and transform translate x minus 30 pixel, move it slightly left initially. This is used for a scroll animation effect, and transform translate x0 moves it back into its correct position. Transition all .6 seconds ease out makes the item smoothly appear when it becomes visible. Now let's dive into the JavaScript that makes our website interactive and dynamic. We start with this function, const animate on scroll. Here we define a function called animate on scroll. A function is like a small machine in your code. You give it some input and it does something with it. The selector parameter tells the function which elements on the page we want to animate. The threshold parameter determines how much of the element must appear on the screen before the animation starts. The default value 0.3 means 30% of the element needs to be visible. Inside the function, we create a new intersection observer. Const observer new intersection observer. An intersection observer is a tool that lets us watch elements and see when they appear in the viewport as the user scrolls. The entries array contains all the elements being observed, and for each element we check if entry is intersecting, entry target class list add active. Entry.isIntersecting is true when the element comes into view. When that happens, we add the class active to the element, which triggers the CSS animation we defined earlier, like fading in or sliding in from the side. Finally, we tell the observer to watch all elements that match the selector. Document, query selector, selector for each element, observer observe. This means every element with the class we provide will animate when it scrolls into view. We then call this function for animate on scroll and scroll animate. This line calls the function and animates all elements with the class scrollAnimate. To finish the hero section, we can add two internal links placed beneath the hero image and paragraph. Let's call it Hero Actions, linking to the timeline and to the projects. Now let's style the buttons in our hero section so they look modern and feel interactive. First, we have the container for the buttons, which we will call Hero Actions. We give it a top margin of 2 rem, so there's some space between the buttons and the text above. Then we use display flags to put the buttons next to each other in a row and gap 1 rem to add some space between them so they don't stick together. This makes the layout clean and evenly spaced. Next, we style the buttons themselves with the button class. We add padding to make the buttons bigger and easier to click. And we round the corners with border radius 12 pixel to give them a soft modern look. We make the text slightly bold with font weight 600, remove the default underline with text decoration none, and we also have two types of buttons, primary and secondary. The primary button uses a bold background color and contrasting text, making it the main call to action that draws attention. The secondary button has a simple border and uses the regular text color from our theme, which makes it subtler but still clickable. We have to adapt the color of the secondary button border when applying the light mode. Therefore, I just use the primary color. Finally, we add a hover effect to make the buttons feel alive. When you hover, the button slightly lifts up using translate epsilon -3 pixel. And we add a box shadow underneath so it looks like it's floating above the page. This gives a modern and interactive feel, making users more likely to click. In short, these styles make our buttons look clean, modern and easy to interact with, while also clearly distinguishing the main action from secondary options. To finish the hero section, we can add a transition of 0.3 seconds, so any hover effects happen smoothly. Next, let's improve the timeline by adding timeline dots. These little dots mark each step or event in your timeline, making it easier for users to follow your journey. The .timeline class is used to style each dot. First, we set position absolute. This allows the dot to be positioned precisely relative to its timeline item, instead of just flowing with the normal page layout. We give it a width and height of 20 pixels, making it a small circle. Then background sets the dot's main color using primary, which matches our primary theme color. To make it perfectly round, we use border radius 50%. We also add a border of 3 pixels using the card color. This creates an outline around the dot, giving it a modern layered look that stands out from the timeline line behind. The left -10 pixel moves the dot slightly to the left, so it sits centered on the vertical timeline line because the timeline itself has some width. The top 0 positions it at the top of the timeline item, aligning it perfectly with the content it represents. Next, let's add and style the little labels that show which technologies were used for each project. These are often called tag badges or pills because of their rounded capsule-like shape. The tag used class is what we use to style them. First, we set display inline block. This makes the badge behave like a text in a line, so multiple badges can sit next to each other, but we can still add padding and margins like a block element. We use font size .8 rem to make the text small so it doesn't overpower the project or content. The background accent gives it a distinct color from the rest of the card, making it stand out as a visual label. Next, padding.3rem.7rem adds some space inside the badge, so the text isn't cramped. Border radius 999 pixels makes the badge fully rounded, giving it that modern pill-like look. Finally, color white ensures the text is readable against the colored background. Next, let's add a scroll indicator at the bottom of our Heroes section. This is a small but helpful feature that gives users a visual hint that there's more content below the fold, so they know to keep scrolling. It's modern and really enhances the user's experience.
This matters because animation isn't just decoration, it's communication.
We start with HTML, div class, scroll indicator and span. Here we have a div with the class scroll indicator. This acts, as always, as a container for our scroll indicator. Inside it we add span, which will become the animated dot inside the scroll frame. Using a span is ideal because it's a simple inline element that we can style and animate easily. Next, we style the span that acts as the scroll frame. Width and height define the size of the scroll frame, making it tall and thin like a capsule. Border 2 pixel solid creates the outline that represents the scroll area. Border radius 999 pixel makes the frame fully rounded, giving it that pill-like shape. Display block allows the span to take width and height. Position relative is important because it lets us position the animated dot inside the frame using absolute positioning. Now let's style the container with the class scroll indicator. The position absolute allows us to place the indicator exactly where we want it inside the hero section. In this case, we want it floating above the bottom edge, so it stays in one spot, even if the rest of the content moves. Bottom 30 pixel moves it 30 pixels up from the bottom, so it's not too close to the edge of the screen. Left 50% centers it horizontally, but since absolute position uses the element's top left corner as the anchor, we'll adjust the inner dot later to center perfectly. Opacity.6 makes the indicator slightly transparent, so it's visible but not distracting. We also handle light mode so the frame adapts to the theme. This changes the frame color when the site is in light mode, so it's always visible. Now comes the animated dot, created with the after pseudo element. The content property tells the browser what the pseudo element should display. The after is a cold pseudo element in CSS. It allows you to create a new element after the content of a selected element without adding extra HTML in your file. Essentially, it lets you insert something purely with CSS. In our scroll indicator, we use span after to create the animated dot inside the scroll frame. Even though there is no div or span in the HTML for the dot, the after pseudo element creates a small stylable element automatically. The after creates a little element after the content of another element without adding anything in the HTML. In our example, it makes a small dot inside the scroll indicator. It will be visible when three things are true. The parent span exists, the dot has to attach to something. The content is set, even if it's empty with empty strings. It tells the browser to create the dot. The dot has styles like width, height, color and shape, otherwise it would be invisible. Because it also has an animation, the dot moves up and down, showing users that they can scroll. In short, the dot only shows up when the parent exists. Content is there and it's styled. In the case of our scroll indicator, we use content and an empty string to create the dot as a real stylable element. even though it doesn't have text. This allows us to position it, give it a size, color, and animate it. We use position absolute, which positions the dot relative to the scroll frame. Top 6 pixels places it near the top of the frame initially. Left 50% and transform translate x minus 50% perfectly centers it horizontally inside the frame. Width and height set the size of the dot. Border radius 50% makes it a perfect circle. Finally, the animation scroll dot itself is defined with keyframes. 0% is the very start of the animation. Here opacity is 0. This makes the element invisible. 40% is 40% of the way through the animation. At this point, opacity is set to 1, which makes the element fully visible. This creates a fade-in effect, so the element doesn't just appear suddenly. 80% is near the end of the animation. Here, opacity is set to 0, which fades the element out again. Animation scroll.2 seconds infinite applies a smooth repeating animation that makes the dot move up and down to signal scrolling. And transform translate minus 50% 0 positions it at its starting point horizontally centered and at the top of the container. And transform translate minus 50% 14 pixels moves it 14 pixels down while it disappears. This gives the effect of the dot sliding down as it fades out. This creates a smooth fade in, slide down, fade out effect that repeats infinitely, giving users a clear visual cue that they can scroll down for more content. We also adjust the dot color for light mode. This ensures the dot is visible on light backgrounds. Let's redesign and improve the header. Top 1 rem pushes it a little down from the very top of the page, and left 50% places it horizontally in the center. But because CSS positions from the left edge, we use transform translate x minus 50% to perfectly center the header. The width calc 100% minus 2 rem makes the header almost full width, leaving some space on the sides so it doesn't touch the edges. Border radius 999 pixels gives the header fully rounded ends, and opacity 0.9 makes it slightly transparent for a modern look. Finally, backdrop filter blur 8 pixels blurs whatever is behind the header, creating a frosted glass effect that looks very polished. Padding 0.75 rem, 1.25 rem adds space inside the header between its content and its edges. The first value, 0.05 rem, sets the top and bottom padding, so the content isn't too close to the top or bottom of the header. The second value, 1.25 rem, sets the left and right padding, giving space between the text or buttons and the edges of the header. Using rem instead of pixels makes the spacing responsive, so it scales nicely on mobile, tablet and desktop screens. Next, let's talk about responsiveness. Responsiveness means making your website look good on all devices, whether it's a large desktop screen, a tablet, or a small phone. Instead of elements staying the same size or layout, we adjust their size, spacing, and alignment so everything stays readable and visually balanced. In CSS, we use media queries to apply specific styles only when the screen meets certain conditions. In this example, add media max width 900 pixels means apply these styles only if the screen width is 900 pixels or smaller. This usually targets tablets or mobile devices. Inside the media query, hero flex direction column text align center changes the hero section from a row layout to a column layout. This stacks the content vertically and centers it, so it fits nicely on narrower screens. Hero actions justify content center centers the buttons or links under the hero text instead of spacing them apart horizontally. Avatar width 150 pixel and height 150 pixel reduces the size of the avatar image so it doesn't overwhelm smaller screens. Body section transition is used to create smooth visual effects when colors change. Transition tells the browser to animate changes instead of applying them instantly. Background color .3 seconds means that any change to the background color of the body or sections will take 0.3 seconds to smoothly transition. Color 0.3 seconds means that any change to the text color will also take 0.3 seconds to smoothly fade from one color to another. This is especially useful for things like dark mode toggles, where the background and text color switch. Without transition, the colors would just change instantly, which looks abrupt. With it, the change is soft and polished, giving your website a modern feel. Let's implement a burger or hamburger menu. This means the menu button is hidden by default, which is perfect for desktop screens because the full navigation is already visible. We only show the menu button when the screen is small, like on mobile devices, using a media query. This is how we make our website responsive. Desktop users see a normal navigation, and mobile users see the burger icon. The order of the style sheets really matters. Font Awesome provides the icons, like the hamburger bars for the menu. If you put your style CSS before the Font Awesome link, your CSS might try to style the icons before they exist, and the icons could appear black, broken, or not show at all. By including Font Awesome first, the icons are loaded, and then your CSS can style them correctly, like making them white sized properly or positioned in your header. Now let's look how we make the navigation responsive for mobile devices using a media query. At media, max width 768 pixel means apply these styles only if the screen width is 768 pixels or smaller, which usually targets tablets or phones. Inside the media query, we first style the nav. We set position absolute so the menu floats over the content instead of pushing it down. Top 70 pixel and right 0 place the menu just below the header on the right side. Background color gives it a color background so it stands out from the page content. Flex direction column stacks the navigation links vertically instead of horizontally, which works better on narrow screens. Padding 1 rem gives the menu button some breathing room so the links aren't cramped. Display none hides the menu by default on mobile because we only want it to appear when the user clicks the burger menu. Next, let's look at the mobile menu button functionality. Const menu button document get element by ID menu button. First, we get references to the menu button and the navigation bar using get element by ID. Then we add a click event to the button. Whenever the button is clicked, it toggles the active class on the navbar. This is what allows the mobile menu to slide in and out when you click the hamburger icon. Then navigation.active display flags shows the menu when we add the active class using JavaScript. This is what happens when the user taps the burger icon. Finally, menu button display block makes the burger menu button visible on smaller screens, so users have a way to open the menu. This small piece of JavaScript is what makes the mobile menu actually work. First, we select the burger menu button using getElement menu button and store it in menu button. Then we select the navigation menu using getElement by ID navbar and store it in nav. Finally, we add a click event to the burger button. Whenever the user clicks it, the code nav class list toggle active adds the active class if it's not there, or removes it if it is. Next, let's look at the Header Actions class, which is used for elements like the theme toggle and the mobile menu button in the header. Display flex arranges the elements in a row, making it easy to align multiple icons or buttons horizontally. Align items center vertically centers the items so they line up neatly in the middle of the header. Gap 1 rem adds space between each item so the icons or buttons aren't squished together. White space no wrap ensures that the items stay on the same line and don't wrap to the next line even if the header gets smaller. By default, clicking on internal links makes the page jump immediately to the section, which feels abrupt and can disrupt the user experience. This line controls how the page scrolls when you click a link or just use JavaScript to move to the page. Normally, when you jump to a section with an anchor link, the page jumps instantly, which can feel sudden. Scroll behavior smooth makes the page glide smoothly to the section instead of jumping.
Here's a big one. We'll retrieve your real GitHub project data. We call the GitHub API. We fetch JSON data, parse and format it. Display repositories dynamically on your site. And we also include error handling. APIs fail, networks fail, users refresh at the wrong time. We'll handle errors properly, catching failed requests, showing a fallback, avoiding broken experiences.
Next up, we want to visualize the GitHub projects. Therefore, we create a grid and use an API to get the data. Now let's look at how we can dynamically load GitHub projects onto our portfolio using JavaScript. First, we select the container in our HTML, where we want the projects to appear. Const projects container document get element by ID and projects. Then we define the GitHub API URL we want to fetch data from. Const API URL and the URL. API stands for Application Programming Interface. Think of it as a messenger between your website and another service. In this case, the GitHub API allows our website to ask GitHub for data about repositories, like their names, descriptions, programming languages, stars, forks, and the last update date. Instead of manually copying this information, the API delivers it automatically. When the GitHub API sends the data, it doesn't send HTML. It sends it in a format called JSON, which stands for JavaScript Object Notation. JSON is basically a structured text format that looks like a mix of arrays and objects. It's perfect for sending data over the internet because it's easy for JavaScript to read and use. For example, each GitHub repository is represented as an object with properties like name, description, language, stargazers count, and so on. We can access each of these properties in our code to display them on the page. To fetch the data from the API, we need an async function. An async function allows us to work with the code that takes time to finish, like fetching data from the internet. Normally, JavaScript runs line by line, but fetching data from a server can take a few milliseconds or even seconds. Using async lets us wait for the data without freezing the page. When we work with external APIs, errors can happen. The server could be down, or the URL might be wrong. To handle this safely, we wrap our code in a try and catch block. The try block lets us attempt to run the code that might fail. The catch block catches any errors that happen and allows us to respond gracefully instead of the website crashing. For example, if the API is unreachable, we display a friendly message like error loading projects. Inside this function, we use await when calling the API. The await keyword tells JavaScript to pause here until the API responds. Without a wait, JavaScript would try to use the data before it's ready, and our website could break or display nothing. Once the API responds, we convert the data from JSON into a JavaScript object that we can work with. Const repos await response JSON. The JSON method takes the JSON text and converts it into objects and arrays that JavaScript understands. From there, we can access each repository's name, description, languages, stars, and more. After converting the JSON, we can sort the repositories, so the most recently updated projects appear first. Then we loop through each repository and create a card for it dynamically using document createElement. Now let's go through this part of the code that creates all the project cards for your portfolio dynamically. This means that every time the page loads, JavaScript automatically creates a card for each project using the live data from GitHub. You don't need to manually update HTML whenever you add a new project. Step number 1. Loop through every repository. For each is a JavaScript method for arrays. It goes through every item in an array and lets you do something with each one. In this case, repo represents one single GitHub repository in each loop iteration. This is how we handle all repositories dynamically, instead of hard-coding them manually. Step number 2. Create a new card element. Const card document createElement div. This creates a new HTML element in memory. It's not on the page yet. Card class name project card assigns a CSS class so we can style each card with the styles we wrote in CSS. Step number 3. Fill the card with content using inner HTML. Inner HTML lets us add HTML content inside an element. Here we use template literals, which are backticks that lets us include JavaScript variables directly in the HTML tag, using the dollar symbol and curly brackets. For example, dollar, curly brackets repo name, insert the repository name from GitHub. Repo languages inserts the programming languages. Using the question marks and empty string, if it's empty or null, it will just display nothing. And the same with the description. This inserts the description or nothing if none exists. This is how the card becomes dynamic, showing real data from GitHub instead of placeholder text. Step number 4. Add repository stats. Repo stargazers count shows how many stars the repo has. Repo forks count shows how many times it's been forked. Repo pushed at is the last update date. We use new date to local date string to turn it into a readable date. This way, each project card shows not just the name, but the real stats that GitHub tracks. Step number 5. Add links. With repo HTML_URL, you can paste the link to the GitHub repository. And repo homepage checks if the repository has a live demo. If it does, it adds a link. If not, it adds nothing. And step number 6. Add the card to the page. Append child inserts the card into the container on the page, making it visible to the user. Because this is inside the for each loop, all repositories get their own card automatically. Next, let's look at the CSS for the project's container, which holds all the GitHub project cards. Display grid turns the container into a grid layout, which is perfect for showing multiple items in rows and columns, like project cards. Grid template columns is a bit complex, but here's what it does. Min-max means that each project card will be at least 260 pixels wide, but can grow to fill the available space evenly. Autofit automatically adds as many columns as will fit in the container. So on wider screens you get multiple columns, and on smaller screens it automatically stacks them into fewer columns. Gap2rem adds space between the cards, both horizontally and vertically, so they don't stick together and the layout looks clean. Let's go through the styling for the project cards in our portfolio. First we have the project card class. Background sets the card's background color using our CSS variable. Padding 1.2 rem adds space inside the card, keeping the content from touching the edges. Border radius 12 pixel rounds the corner, give it a softer modern look. Box shadow adds a shadow to make the card appear slightly lifted off the page. Next we have the hover effect. Project card hover. This moves the card slightly upward when you hover over it, giving it a nice interactive feel, using transform, translate epsilon and -6 pixels. And transition 0.3 seconds makes any changes to the card, like hover effects, smooth and animated rather than abrupt. Because of the transition we added, the movement is smooth and pleasing. Now for the text inside the cards, the repository name .repo name, we use font weight 600, which makes the text bold so the project name stands out. Font size 1.1 rem sets a readable size for the name. Margin button .3 rem gives space between the name and the next piece of information. The programming language of the project is styled by repo language. The font size is slightly smaller than the name, so it's secondary information. Color highlights the language using our accent color. Margin button .5 rem separates it from the description below. To style the project description, we use font size .9 rem to keep the text readable but smaller than the title. Opacity .85 makes it slightly faded to visually prioritize the title and language. Margin bottom .7 rem adds space before the stars or links. To style the project stats like stars, forks and last update, we use font size .75 rem, so the font is smaller since it's less important information. We set the opacity to 0.7, which makes it lighter so it doesn't compete with the main content. And margin bottom 0.8 rem to separate it from the links and the bottom of the card. Finally, the project's links. Text decoration none to remove the default underline from the links. Padding 0.4 rem and 0.7 rem to add space inside the link to make it feel like a button. Border radius 6 pixels rounds the corners of the links. Margin right 0.4 rem adds a small gap between multiple links. Color white ensures the text is readable on the bottom background. Then we style the two types of links separately, GitHub link and demo link. GitHub link has a dark background to match GitHub's color. Demo link uses our accent color to visualize, stand out and indicate a live demo. Let's start with the styling for sections and headings on the page. First, the section rule section, padding 5 rem, 2 rem, adds space inside the section. The top and bottom get 5 rem of space, and the left and right get 2 rem. This prevents the content from touching the edges and makes it look clean and spacious. Max width 1200 pixels ensures that on very wide screens the content doesn't stretch too much, keeping it easy to read. Margin auto centers the section horizontally in the page. This is what keeps the content nicely aligned in the middle of the screen. Next, the H2 heading rule. Text align center centers the heading horizontally. Font size 2.2 rem makes the heading large enough to catch attention, but not too big to be overwhelming. Margin bottom 2 rem adds space between the heading and whatever comes below, like a paragraph or a card grid. And color primary sets the heading color using our CSS variable, which ensures it matches the main theme of our site. Now let's look at the YouTube call to action section of the website. This section is designed to encourage visitors to subscribe to a YouTube channel. In the HTML, we have a section with the ID YouTube CTA. Inside it, there is a div with the class CTA wrapper, which contains a heading, a paragraph, and a link styled as a button. The section element is used to group all related content for this specific part of the page. The CTA wrapper div organizes the heading, paragraph, and button vertically. The H2 is the main heading of this section, telling visitors what the CTA is about. The paragraph provides a short description and encourages people to visit the YouTube channel. The anchor link is styled like a button, using classes btn and primary, making it visually stand out. Now let's go through the CSS for this section. Background sets the background of the section using the theme's card color. Color makes sure the text is readable and matching the theme. Border radius 20 pixels rounds the corners for a smooth modern look. Padding 5 rem and 2 rem adds space inside the section so the content doesn't touch the edges. Margin 4 rem and auto adds vertical space from other sections and centers the section horizontally. Text align center centers all the text inside the section. Box sizing border box ensures padding is included in the element's total width. Max width 90% VW limits the width so it looks good on different screen sizes. Display flags and justify content center centers the wrapper div horizontally inside the section. Box shadow adds an outer shadow for depth and an inner border using inset for extra style. Next, the wrapper inside the section. Display flags turns it into a flexible container. Flex direction column stacks the heading, paragraph, and bottom vertically. Align items center centers everything horizontally. Gap 1.5 rem adds space between each element so they're not too close together. The heading H2 inside the wrapper is slightly larger to stand out. Margin bottom 0.5 rem gives space before the paragraph. To style the paragraph text, we use font size 1 rem to keep it readable. Opacity 0.9 makes the text slightly softer than the heading, emphasizing hierarchy. Line height 1.6 increases spacing between lines for better readability. Margin bottom 1.5 rem separated from the bottom. Finally, the button styling inside the wrapper. The bottom text is readable and clearly clickable with font size 1 rem. The padding 0.9 rem and 1.6 rem adds space inside the bottom for a nice clickable area. Border radius 12 pixels gives it a round corner, matching the section style. Next, let's talk about scroll animations and how we can make elements appear smoothly when the user scrolls down the page. The class we use for this is called scrollAnimate. Let's break the CSS down step by step. Opacity is set to 0 means the element is completely invisible at first. Transform translate epsilon 40 pixels scale 0.9 moves the element 40 pixels down and makes it slightly smaller at 90% of its original size. This gives the effect that it's floating up and growing as it appears. Transition 1 second defines how the changes happens. It lasts 1 second and uses a cubic curve which makes the movement smooth and natural, rather than linear and abrupt. Scroll animate activate. When we add the activate class via JavaScript, the element becomes visible. Opacity is now set to 1, which makes it fully visible. Transform translate epsilon 0 and scale 1 moves it back to its normal position and restores it full size. In simple terms, this CSS makes elements fade in and slide up as the user scrolls down the page. At first, they are hidden and slightly smaller, and then when they reach the viewport, the active class is added, causing a smooth transition into view.
Now we bring AI into our workflow, intentionally, not to generate code, but to generate images and videos.
How to create a scroll animated hero background using WebP images. Step number 1. Prepare your hero image. First, go to Whisk and upload the image you want to use as your hero image. Adjust it as needed to make it visually appealing and ensure it fits the size and style you want for your website. Once you're happy with how it looks, set it as your hero image. Step number 2. Animate the hero image. Next, click on the Animate option in Whisk. You will see a prompt field where you can describe the type of movement you want for your image. For example, you could ask for a new direction of the camera angle. Use this to generate the animation and review the result to make sure it looks natural and smooth. Step number 3. Export the animation as a video and split it into frames. Once your animation is ready, export it as a video file. Then go to SGIF or any similar website that can convert a video into individual images. Upload your video and select the option to split it into frames. Make sure to choose high quality output so your images remain crisp. After the process is complete, download all the frames in WebP format, which is ideal for websites because it balances high image quality with small file sizes. And step number 4, organize the images in your project. In your website project directory, create a folder called Images. Move all the downloaded WebP frames into this folder. Make sure the images are named sequentially, for example, frame1.webp, frame2, frame3, and so on. Sequential naming will make it much easier to control the animation later. Now let's integrate the images into our hero section. First, we have a simple loader element. This line creates a div with the ID loader and displays the text loading. We use this to let users know that the animation frames are still loading before the animation starts. Next, we have the scrollable hero section container. The first div has the ID hero scroller. This acts as the main scrollable container. Its height will be set very tall in CSS so that the user can scroll and trigger the animation. Inside this container, we have another div with the ID sticky view. This is a sticky container that stays pinned to the top of the viewport while the user scrolls. Inside this sticky container, we have a canvas element with the ID hero canvas. This canvas is where we will draw all of our animation frames, making the scrolling animation smooth and efficient. Now let's move to the JavaScript. We start with some configuration. We declare a constant called frameCount and set it to 120. This represents the total number of frames in our animation, numbered from 0 to 119. Then we create an empty array called Images. We will use this array to store all the preloaded frames of the animation. Next, we grab the canvas element from the DOM using document getElementById hero canvas and store it in the canvas variable. Finally, we get the 2D drawing context from the canvas by calling canvas getContext2D and store it in CTX. This context allows us to draw images and shapes onto the canvas. Next, we grab some other elements from the DOM: scroller, document get element by ID hero scroller, and loader, document get element by ID loader. Here we get the scrollable container by its ID and store it in the variable scroller. We also get the loader element and store it in the loader variable. We will use this later to hide it once the animation frames are ready. Now we define a function to preload all images. We create a function called preloadImages. Inside this function, we declare a variable loadedCount and set it to 0. This variable keeps track of how many frames have finished loading. Next, we run a for loop that goes from 0 up to the number of frames. For each iteration, we create a new image object and store it in a variable image. We format the image number as a 3-digit string using pets.3 and 0. So frame 0 becomes 000 and frame 1 becomes 001 and so on. Then we set the source of the image to the path images frame and xxx webp, where xxx is the formatted frame number. We also add an onload event to the image. Every time an image finishes loading, we increment loadedCount by 1. If all frames are loaded, meaning loadedCount equals frame count, we call the startApp function to begin the animation. Finally, we add each image to the images array. This ensures that all frames are stored and ready to be drawn on the canvas. Next, we define a function to size the canvas. This function sets the canvas width to the full width of the window and the canvas height to the full height of the window. After resizing, we call updateImage with the current frame index so that the canvas displays the correct frame immediately. We also listen for window resizing. Window add event listener resize canvas. This ensures that whenever the user resizes the browser window, the canvas adjusts to the new size and redraws the current frame. Now we calculate the scroll progress. We define a function called getScrollProgress. Inside this function, we get the position and size of the scroll container relative to the viewport using getBoundingClientRect. We take the top value of the container as the starting point and calculate the total scrollable height as the container height minus the window height. We calculate progress as the negative top position divided by the total scrollable height. This gives us a value between 0 and 1 that represents how far down the user has scrolled. Finally, we use mathMax and mathMin to make sure the progress is always between 0 and 1. Next, we calculate the current frame based on scroll progress. We define a function called getCurrentFrameIndex. Inside we get the scroll progress and multiply it by frame count minus 1 to determine the index of the current frame. We use mathFloor to round it down to the nearest whole number. Now we define the function to draw the current frame on the canvas. We define a function called updateImage that takes the frame index as a parameter. The first line checks if the image exists in the array. If it doesn't, we exit the function. We get the image for the given index from the images array. We define crop values for the top, bottom, left and right edges. These allow us to cut off a few pixels if needed. We calculate the source width and height by subtracting the crop values from the original image dimensions. Next, we calculate horizontal and vertical ratios to scale the image to the canvas, to ensure the image covers the entire canvas. We calculate the final draw width and height using this ratio, and we calculate offsets to center the image on the canvas. We clear the canvas first using clear rect, then draw the new image using draw image with crop, scale and offset values. Next, we handle the scrolling. We define a function called onScroll. Inside, we calculate the scroll progress and the current frame index. We use request animation frame to update the canvas efficiently. This ensures smooth animations that sync with the browser's refresh rate. We then call update image with the current frame index to redraw the canvas. Finally, we define a function called startApp. First, we hide the loader by setting its opacity to 0. Then we use setTimeout to remove the loader from the DOM after half a second. We call resize canvas to make sure the canvas matches the viewport size. We add a scroll event listener to the window so that the onScroll function is called whenever the user scrolls. Finally, we call onScroll once to render the initial frame immediately. At the very end, we call preload images to start loading all the animation frames. Once they are all loaded, the app will start automatically. Let's start with the CSS for the scrollable heroes section. Here we select the element with the ID hero scroller. We set its height to 400 VH. This means it is 4 times the height of the viewport. We do this so that there is plenty of scrollable space, which allows our animation to play fully as the user scrolls down the page. Next, we set position relative. This is important because any child elements with absolute positioning, like our canvas, will be positioned relative to this container. Next, we style the sticky container. Here we select the element with the ID sticky view. We use position sticky and top 0. This makes the container stick on the top of the viewport as the user scrolls. It will stay visible until the scrollable parent, hero scroller, scrolls out of view. We set the height to 100 VH and the width to 100%, so this container fills the entire viewport. We use overflow hidden to make sure that anything inside this container that goes outside its bounds, like parts of a canvas image, will be hidden. Then we use display flags along with align items center and justify content center. This centers the canvas horizontally and vertically inside the sticky container. This ensures that the animation always stays perfectly in the middle of the screen. Finally, we style the canvas itself. Here we select the canvas element. We use position absolute, which allows us to place the canvas precisely inside the sticky container. We set top 50% and left 50%, which positions the top left corner of the canvas in the center of the container. To truly center the canvas, we use transform, translate, -50% and -50%. This moves the canvas up and left by half of its width and height, so the center of the canvas aligns with the center of the container. We set min width to 100% and min height to 100% to ensure that the canvas always fills the sticky container. This prevents empty spaces on the sides or top and bottom of the screen. We use object fit cover so that the images drawn on the canvas scale proportionally to cover the entire area, even if the canvas size changes. Finally, we set the set index to 1 to place the canvas above any background, but below any other potential elements we may want to layer on top, like text or buttons. To make the hero section more pop, let's add some text showing up when scrolling down. Inside the sticky container, we have two text blocks. Text right is positioned on the right side of the screen, and text left is on the left side. Both have the class hero text, which gives them shared styles like starting invisible and being absolutely positioned over the canvas. These texts live inside the sticky container, so they scroll with the animation, but remain pinned to the viewport while appearing or disappearing. They are absolutely positioned over the canvas using position absolute and stacked above with the set index set to 10. Both texts start invisible, using opacity 0, and slightly below their final position using translate epsilon and 40 pixels. When the visible class is added via JavaScript, the text fades in and moves upward smoothly thanks to the transition. Text right is anchored 10% from the right and aligned right, while text left is anchored 10% from the left and aligned left. When the visible class is added via JavaScript, the text fades in and moves upward smoothly thanks to the transition. Now let's explain the JavaScript that controls when the text appears. We grab references to both text elements from the DOM so we can manipulate them with JavaScript. Inside these functions, we first check the scroll progress. For text right, we make it visible when progress is between 0.1 and 0.45. If the progress is outside this range, we remove the visible class so it fades out. For text left, we make it visible when progress is between 0.55 and 0.9. Outside this range, we hide it. Next, we calculate the parallax offset. This takes the scroll progress and multiplies it by 100. In this if statement, we check if the right side text currently has the visible class. If it does, we update its transform style dynamically, using transform epsilon minus 20 plus progress minus 0.1 times 50. Minus 20 starts the text slightly above its final resting point for a smooth entry. Progress minus 0.1 calculates how far the scroll has progressed since the text became visible. Times 50 scales this movement so that as the user scrolls further, the text moves upward by up to 50 pixels. This creates an upward floating and parallax effect for the text as the user scrolls. And the same idea we can apply to the left side text. It only moves if the left side text is visible, and using the formula translate minus 20 plus progress minus 0.55 times 50 means minus 20 initial offset upward, progress minus 0.55 calculates scroll progress, and times 50 scales the upward movement. Finally, the onScroll function calls update text along with updating the canvas frame. Every time the user scrolls, we calculate the current progress, draw the corresponding frame on the canvas, and update the text position and visibility of the frame. And there you have it. Your website is finished. Now let's put it online.
The last step is the most important one. Finally, we ship it. We'll push the project to GitHub, structure the repo correctly, enable GitHub pages, and go live with a real URL you can share. This step matters more than people think. A live project builds confidence and credibility.
You can easily create a repository on GitHub and upload individual files to it. Just be aware that there is a limit of 100 files per upload using this method. Therefore, I had to adjust the number of the frames in the images folder to reduce the files and adapt the frame count in JavaScript. After uploading the files, go to Settings, Pages, and Build and Deployment. Select the source and choose GitHub Actions. Go to Static HTML, click Configure and Commit Changes. In the Actions section, you see the progress of the deployment, which takes about 20 seconds. When the workflow is completed, head back to Pages to see your URL. Now your website is live. The next step would be to buy a domain on, for example, Hostinger and connect it to the website. Of course, you can choose another platform to deploy, like Vercel or Netlify.
Now build your own projects. If you enjoyed this video, give it a like and subscribe for more HTML, CSS and JavaScript tutorials.